Find an irrational number between 1 by 7 and 2 by 7. Try this.
Sir, 0.15115 and so on.
And how did you get it?
Sir, I took approximate value of 1 by 7 as 0.1.
You took the approximate value of 1 by 7 and 2 by 7. So you can start from 0.15. There can be several ways. One way is this way. Any questions? Let me know. Next, is this rational or irrational?
Rational.
Rational. Because 196 is perfect square. So it is rational. How about this?
Irrational.
Irrational. Irrational is right. 21 is not a perfect square. How about this?
Rational. Sorry, irrational.
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 Yes. Then how about this?
Irrational.
Sir, irrational. Sir, irrational.
Rational. So
Okay.
rational.
Which property have we used to say that it is irrational?
The rational number plus irrational number is an irrational number.
Perfect. Rational plus irrational is irrational. That's property. How about this one?
Irrational.
Irrational. Same property. You can say subtraction here. Rational one number, irrational another number. How about this?
Irrational.
Irrational. And the property here is that one rational number 2 by 3, another irrational number √6. Their multiplication. Irrational. How about this?
Rational.
Rational.
Rational. Then how about this one?
Irrational.
Irrational. Because there is no repetition that is taking place, it is irrational.
So in the end, it is 323. I understood it as 333.
Yes, 333. How about this?
Irrational.
Irrational.
Irrational. How about this?
Rational.
Rational.
Rational. The property is that it is terminating. How about this one?
Irrational.
Anybody else?
Sir, it's rational.
So
Rational.
it's rational. It can be expressed in the form of P by Q.
It is basically this. Any questions? Let me know. And how about this one?
So that's rational.
Sir, pi is irrational.
I is irrational.
So why is pi irrational? It can be expressed in the form of P by Q.
That's an approximate value. Pi is approximately this. It is not equal to this. You know what is the value of pi? Just a moment. The value of pi it's not complete, by the way. And what is the value of 22 by 7? 22 by 7 is approximately 'check if they are equal or not. You will know it from the third place after decimal itself that they are not equal.
Sir, the digits after the decimals recur.
In which one?
22 by 7.
Yes, yes. So I have approximated that. It is 4, 2. After 2, 8 is there. And that 8 has rounded. That 8 has made 2, 3. So what you are seeing is not the full expansion of 22 by 7. It will be 2, 8, and so on. Okay, anything else regarding this? Just for your knowledge, there is one more number called E. Constant. One more constant called E in mathematics. And that E is also irrational number. Its value, of course, will just keep on going. 2.7 is the approximate value of E. 2.7.
So for what is E used for?
It is used in higher mathematics, but I can give you something simple. Where this is called factorial. Factorial is something very simple which you can understand right now. Factorial 4 means 1 into 2 into 3 into 4. Factorial 5 means 1 into 2 into 3 into 4 into 5. It just goes on and on and on, never ends. Infinite series it is. You can see 2 is already done. 1 plus 1 is 2. Factorial 2 is basically 1. Factorial 2 is 2. 1 by 2 is 0.5. So 1 plus 1, 2 plus 0.5, 2.5 we are already done. All the terms after that add up to give only a little bit more, 0.2 something. So you just need to have a rough idea of E, not in your scope right now. Next question. Is 22 by 7 rational or irrational?
Rational.
Irrational.
Why did you say irrational? It is P by Q.
Oh, sorry, sir. It's rational.
Now, we have talked about number line. We have represented several numbers, including decimals. How to represent some irrational, well-known numbers like root 2, root 3, etc. Let's see on the number line. And by the way, now I can call it a real number line. So what is a real number? Real number includes all that we have discussed up to this point. Natural, whole, integer, rational, irrational. All together are called real numbers. So that line is called real number line. How to represent root 2 on real number line? That's quite simple using Pythagoras theorem. Mark 1 unit. Then take compass, or let's not complicate. Draw a line perpendicular, whatever way you want to draw. Perpendicular. Cut the same length here. So this is 1 unit. This is also 1 unit. Join these two. Let the length of it be x. You're not going to measure it. You're just calling it x using Pythagoras theorem. But length can never be negative. So rejective negative solution. It is plus root 2. But if one doesn't write anything in front of root 2, it is taken to be positive. That's a convention we follow. So x is automatically root 2. Now, place the needle of your compass here. Measure this just using your compass. No need for your scale or ruler. And then rotating it, cut it here. Cut dark here, right? This point is your root 2 point on the real number line. This point is 1 unit point, this point is root 2 unit point. So I hope you have understood the concept. It is no magic, but just Pythagoras theorem that gave us this length as root 2. Because x is root 2, this is also root 2. Any questions? If you have, then let me know. If you have understood that, then can you mark route 3 showing the construction procedure roughly on the board? You can use the board if you want and mark route 3 here on this line. Just approximation will do. The way I have done it, it is just approximation that I have done. This is not going to be accurately route 2. Okay, conceptually I don't see anything wrong. We can make it a little more accurate, but conceptually it's fine. So X is route 2. Construct a 90-degree line. Construct a 90-degree line. And its length is 1 unit. Now join these 2 points. I will just rotate what is already there. Now using Pythagoras theorem, for this triangle you will find it to be route 3. If you have any problem with that, let me know. Since we know it is route 3, put the needle of the compass here, take this measurement and cut an arc. And you are done. Where it cuts the line, that point is route 3. So this length will be route 3. Any questions? Let me know. Can you mark under root 10 on this line in the shortest possible way without multiple constructions? How will you mark root 2? You can use the board if you want. You can do it faster. This is okay, but you can proceed from root 2, but you don't need it. So try something else. You don't need root 2 to get root 10. There is a very simple method, very simple, with no complication at all. That's what I'm looking for. And we have discussed that method. You just have to fit suitable values. I'm not asking you something which we have not discussed. Fit the suitable values. Okay, I'm giving you the hint. Find two numbers such that their squares add up to 10. Yes, you can
So
go ahead if you
1
got it.
square and 3 square.
1 and 3.
So go ahead then. You already know. Three and one you need, right? That's it. Yes. That's it. So this is the arc cutting here. So that's the exact method. One can of course mark these points by finding the decimal value. So one can obviously say that take root 2 as nearly 1.4 and then mark 1.4. But technically it won't be accurate to a great extent, technically. But this is technically absolutely accurate, the procedure. When you practically do it, it may not be very accurate because your pencil has got some thickness and even other things that you use, they may have errors associated with them, some degree of errors. But logically this is error free. Likewise, how will you get root 7 in a quick way? Root 17 in a quick way.
Sir, 1 square plus 4 squared.
That's it. 1 square plus 4 square whole under root. Now answer this question. This is, let's say, the reference point, like origin. Right side is plus, left side is minus. This is 1 unit, 1 unit, 1 unit, 1 unit, 1 unit. 90, 90, 90, 90. This is the arc of radius OA. This is the arc of radius OA. Then this point is which point? This point is which point?
Root 6.
Others can also try.
Sir, -2.
Can you repeat?
-2.
-2. Okay, anybody else?
Sir, -√5.
-√5. Okay, anybody else? I'm not saying it is wrong. Let's see. 1, 1. So this is √2. Again, in this triangle, applying Pythagoras theorem. For this triangle, this is √3. Then for this triangle, applying Pythagoras theorem, √4. Then for this triangle, applying Pythagoras theorem, √5. Same radius, you are taking √5, √5. So -√5 is the correct answer. Now, any questions? If you have, then let me know. So if you understood it, then tell me this question, answer to this question. Suppose I keep on drawing in this manner, ditto, same manner. Then to get √17, how many small triangles, how many triangles of this type do I need to draw? To get √17, how many triangles do I need to draw? Triangles like these.
16.
16. Okay, anybody else?
Triangles, sir. 16 small triangles. 16.
16. Okay, anybody else? I think they are both correct. One triangle if you draw, you get √2. Two triangles if you draw, you get √3. Three triangles, one triangle √2. Two triangles √3. Three triangles √4. Four triangles √5. So if you want to get likewise √17, then shouldn't this number on the left be one less than this? 16 triangles. That is if you follow this slow method. √17 you can get in a smarter way, just by one triangle. Both of these are approximate values of pi, both of these. My question to you is that which of these is a better approximation for pi? So this is your assignment. Which of these is a better approximation for pi? That's your assignment. We stop now.